Hi guys, welcome to Dharani's Max channel. Before going into this video, please like and subscribe for more videos. In this video, we are going to cover the solved examples before 1.1. So let's go. Sums based on what we learnt. So in the previous video, we have discussed the chapter's introduction, sets of numbers and their definition, and some more examples, etc. So here we are going to discuss the sums related to what we discussed in the previous video. So the first sum, that is example sum, are the following statements true or false? Give reason for your answers. So the question will be given as statements and the answer should be true or false. If true, we should give reason. If false, we should give a reason. Give reason for your answers. First subdivision. Every whole number is a natural number. So what is whole number? Whole numbers are the numbers that starts from 0. Natural number are the numbers starts from 1, 2, 3 and so on. So the numbers starting from 0, 1, 2, 3 are whole numbers. They have 0. But you can't see 0 in natural numbers. So 0 can't be seen in the natural number. So every whole number is not a natural number. Solution: false, because 0 is a whole number, not a natural number. Second subdivision. Every integer is rational number. So what are integers? Integers are the positive, negative and 0. So positive, they must contain plus symbol defaultly. Negative, they must contain minus symbol. And 0, you know very well, it is either positive or negative. Then rational number. Rational numbers are integers, that is in the form of p by q. So p by q are integers and q is not equal to 0. So integers can also be represented in the form of rational number by defaultly 1. In the previous video, I said example 5. So 5 is an integer and it can be represented in the rational form by defaultly adding 1. So here the solution: true, because every integer m can be expressed in the form of m by l. So m here represents to any number and l, where l is defaultly 1, so l is equal to 1. So it is a rational number. I hope you understood. Third subdivision. Every rational number is an integer. Again, rational number is p by q, where p and q are integers and q is not equal to 0. Integers. Integers are numbers of positive, negative and 0. You know very well integers as well as rational number, as I said many times in this video. Solution: false, because 3 by 5 is a rational number but not an integer, because rational number are in the form fractional form. Integers can be in the form fractional form, but the denominator should be 1. So it cannot have any number than 1 in the denominator, so it is not a integer. Next is example 2. Find 5 rational numbers between 1 and 2. So here we have two methods and I am going to show the both. First method. So for finding anything in mathematics, we use the apply formula. So here the formula is half, that is 1 by 2, r plus s, or r plus s by 2. So this can be expressed in the form half r plus s, that is into r plus s. How means? R plus s divided by 2 should be made in the form r plus s, the symbol divided, that should come 2. So when division symbol change to multiplication symbol, for dividing we should change the division symbol into multiplication symbol. So when we change, the 2 will get its reciprocal, that is 1 by 2. So it changes into this form. So they have given only two numbers. I am going to take R as 1 and S as 2. We cannot change it as R is equal to 2 and S is equal to 1 because they have asked to find 5 rational numbers between 1 and 2. Okay, you can change, but yeah, you will get correct answer. So the next, R is equal to 1, S is equal to 2. According to this formula, I am going to add both. So 1 plus S by 2, which is equal to 3 by 2. 2 plus 1 is equal to 3, by 2 remains same. So the rational number between 1 and 2, that is first rational number I have represented here, is 3 by 2. So the 3 by 2 is the rational number between 1 and 2. They have asked to find 5 rational number. So the second rational number is R is equal to 1 and S is equal to 3 by 2. So I am going to again do as per this formula. So 1 by 1, it is an integer without denominator. So defaultly it will come as 1 by 1 plus 3 by 2. It cannot be added because the denominator is not same. So I am going to take LCM between 1 and 2. So 1 cannot be simplified and 2 can be simplified. That is 2 into 1 is equal to 2. So the only number left over here is 2. So the LCM is 2. So the denominator should be 2. To make it as the denominator as 2, we have to multiply it with a number. So 1 by 1 into 2 by 2, which makes the denominator 2. So 1 into 2 is equal to 2. 1 into 2 is equal to 2. Here in this number, you can see the denominator already 2. So no need to multiply with anything, just I have multiplied it with 1, which makes no change. So 3 into 1 is equal to 3, 2 into 1 is equal to 2. By 2 remains the same. So when adding, we get 5 by 2. That is 2 plus 3 is equal to 5 and by 2 remains the same, divided by 2. So when we take the divided by 2 as in the symbol division symbol, it will change into multiplication symbol, and while changing it will take the reciprocal of 2, that is 1 by 2. So what is reciprocal? When an integer or a rational number having defaultly 1 in the denominator or any other number, when taking into alternative way, that number is called reciprocal of the number. So for example, 3 by 5 reciprocal is 5 by 3. 4 by 8 reciprocal is 8 by 4, etc. So 5 by 1 is equal to 5, 2 into 2 is equal to 4. So the 5 by 4 is another rational number between 1 and 2. So 5 by 4 is a rational number between 1 and 3 and 2. As we have taken R is equal to 1 and S equal to 3 by 2. So between them 5 by 4 is the rational number. Thus I have given here 1 and 3 and 2. Next, third rational number. Here the third rational number can be taken as any way, that is R is equal to 1 or S is equal to 5 by 4, or R is equal to 5 by 4 or S is equal to 3 by 2, or R is equal to 3 by 2 and S is equal to 2. So that is what we are going to take here. But the answers may differ, and you can get the correct answers. So when adding, the 2 will get defaultly 1, and it cannot be added because the denominator is not same, so we have to take LCM for 2 and 1. While taking 1 cannot be simplified, so 2 remains. So 2 into 1 is equal to 2. Here the only is 2, so LCM is 2. So we have to make the denominator as 2. Here 3 by 2 is already has the denominator as 2, so no need to multiply with anything. So I have just multiplied it with 1 by 1. Next, 2 by 1, to make a denominator as 2, we have to multiply it with 2. So 2 into 2 is equal to 4, 2 into 1 is equal to 2, and 3 into 1 is equal to 3, 2 into 1 is equal to 2. So when adding, and the by 2 will remain the same here. When adding, 3 plus 4 is equal to 7, by 2 remains here. When divided by 2, it changed to multiplication symbol with the reciprocal of 2. So the reciprocal of 2 is 1 by 2, as I told in the before methods. 7 into 1 is equal to 7, 2 into 2 is equal to 4. This is the third rational number that we obtained. Find 5 rational numbers between 1 and 2. So they have given 5 rational numbers to find, and I have given only 3 rational numbers. So you can put the rest 2, that is in the method 1, in the comment box, and I will upload the answers in the next video. Method 2 is going to be very simple, and you can see here the method 2 is over. So 1 and 2. To find rational numbers between 1 and 2, we are going to take the integer 1 and 2, and the denominator is going to be defaultly 1. So when we take defaultly 1, we have to multiply it with something to increase the value, as there is no rational numbers found between them, and they have asked to find 5 rational numbers. So when they have asked to find 5 rational numbers, we have to take a number just greater than that. So 5, after that 6. So I am going to multiply it with 6, so that you will get exactly 5 rational number when you increase the value. If you want to get more than that, it's nothing, no problem. You can take even 10, 9, 8, etc. and more than that. So when we multiply with 6, 1 into 6 is equal to 6, and again 1 into 6 is equal to 6. 2 into 6, that is I am going to multiply it with again 6, as both numbers should be multiplied with same to get the denominator same. 2 into 6 is equal to 12, 1 into 6 is equal to 6. When you cancel, you will get again 1 by 1, here also the same, again 2 by 1. So 6 into 1 is equal to 6, so 1 will remain here, and 6 into 1 is equal to 6, again 1 will remain here. 6 into 2 is equal to 12, so 2 will remain here. 6 into 1 is equal to 6, 1 will remain here. So these are the numbers that we have obtained from 1 and 2 by increasing the value. So you can see 5 rational numbers between these two numbers, so that only we have increased the value, and the numbers are 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6, and these numbers can also be cancelled. When we cancel that, the numbers that obtained can also be the numbers between 1 and 2. So when we cancel 8 by 6, as 8 and 6 goes into 2 into 4 is equal to 8, so 4 remains here. 2 into 3 is equal to 6, 3 remains here. So the number 8 by 6 is equal to 4 by 3. So here you can see equivalent rational numbers. The denominators are same, denominators are different, and the values are same. And the next 9 by 6 can be simplified to 3 by 2, as 9 and 6 goes in 3. 3 into 3 9, so 3 remains here. 3 into 2 6, so 2 remains here. 3 by 2 is obtained here. Then 10 by 6 also goes in 2. 2 into 5 is equal to 10, so 5 remains here. 2 into 3 is equal to 6, so 3 remains here. So the numbers obtained are 7 by 6, 4 by 3, 3 by 2, 4 by 3, 5 by 3, 11 by 6 are the 5 rational numbers between 1 and 2. That's all for this video. Thanks for watching. Subscribe the channel, like, comment and share. See you in the next video.